And good morning, everybody. Hopefully, my voice doesn't sound too bad. I'm currently hopped up on Codral and caffeine, and that's the way I'm getting through the day today. But that's what we've got to do. I've got audio. Am I online? It looks like I am. I think we're here. Okay, so before I get into saying good morning to everybody, I acknowledge the traditional owners of this land, the Whadjuk Noongar peoples. I pay my respects to their elders, past and present, and to Aboriginal elders and peoples from other communities who may be taking part in this live stream today. So, thank you very much. And good. Good morning to everybody. So, who have we got here? Dodgy, Amanda, some call it fun. Chip is here. Mitchell, Cable Tie, Cabletti. Yes, you're here at the start. You're not on a bike ride, but it's a perfect day. If you're in Melbourne today, it is like the definition of a perfect day, for me at least. I don't like it when it's stinking hot. I like it when it's, I suppose the ideal temperature would be like 20 degrees. I don't even know what the temperature is right now, but there's sunshine outside. I like it when it's sort of slightly coolish, but a bit of sunshine. Who else is here? Dodgy? Did I say hello to Dodgy? I don't know. Mitchell, Delane, Stephen, Family Plans, Gerald, David, Javier. Hi from the past. Hi from the past? Are you is that a time zone thing? Or is it that you haven't been to the streams for a while? Okay. What have I missed? Someone said, Dodgy said, a good catchphrase isn't wasted on us. Cable Tie. Where is Cable Tie? Cable, what did Cable Tie say? I don't know. I'm missing whatever is going on in the chat. There is stuff there that I'm not aware of. So, back on the caffeine. Hey, yes, Mad Techie, I am back on the caffeine. But so Cable Tie said, today is a beautiful day. I got lazy this morning, just did an hour on the trainer instead. An hour on the trainer. Yeah, you're so lazy. We all think you're so lazy, Cable Tie. Oh, Javier, Saturday night here. Okay, that's what you mean. Yes, it's a time zone delta. Gerald, thank you for the birthday contribution. Oh, I appreciate it. Yes, it was my birthday a few days ago. How many days ago? Approximately 4 days ago, according to the thing. Oh, I don't know if I can... Should I do this? I think this is okay because he's mentioned it previously. So this is not a doxing sort of thing. That means it has also just been Outside the Box's birthday. So happy birthday to Outside the Box. We don't actually quite have the same birthday, but it is very close. And well, the funny thing is, because I was born in London, if I celebrate my birthday at the actual time it would have happened in GMT, because of the time zone difference, I think that means that Outside the Box and I were technically within the same 24-hour period. Yeah. So, yeah, we were born within the same 24-hour period, like different dates, but different time zones on opposite sides of the world. So, Dodgy, yes, I was born in London. I was born in Kensington, a little suburb of London. Sounds like I'm going to need some tissues. I don't know. Hopefully I will not sound too bad for this. Okay, I don't want to have too much preamble because there is a whole lot of stuff that I want to get done today. I really want to get straight into this, into the design of this board. We had all of the... Oh, Mitchell, thank you for gifting those memberships. That's very generous. Cable Tie says, oh my God, John is POM. Technically, well, sort of. I qualify for dual citizenship, and but I am an Australian citizen. And I've been here pretty much my whole life. So, okay. There is a big squirrel that I will not chase. I will just mention it and say, oh, there goes a squirrel, which is the whole licensing debacle, which we saw the start of on the live stream last week. On Tuesday, sometime Saturday morning last weekend, my Eagle license and my Fusion 360 license got cut off without warning. And I ended up on a trial version. So when I was trying to do the board design last Sunday, I was running Eagle in trial mode, which meant that I was limited to 2 layers and a very small board size. And I couldn't put parts down in negative coordinates and limitations like that. Very frustrating. So then I ended up sending a what is going on request, because I've been on a full pro subscription for Eagle for 12 years, 13, something like that. It's been a long time. I've been paying like the full pro license, unrestricted, do everything sort of thing, top tier. And then, but of course, most of that time they weren't part of Autodesk. And then when it became part of Autodesk, I switched over to a full pro subscription on Fusion 360, which I've had for years. So I've been paying that on auto renewal for years. And for some reason, I ended up being cut off, and it's still not resolved. Basically, I've had totally useless responses from Autodesk customer service saying, if you follow me on Twitter, I posted some stuff on there, but the initial response I got from them was, find the contract and show us. It's like, what the hell? Why should it be up to me to go to find the contract to prove that I've been paying a subscription? Anyway, I said I wasn't going to chase this squirrel, so I'm not going to get into it. But the important thing is that it leads to the question of what to do now. And there are really 2 paths that I can follow. Path the first is take the existing design. So this is ignoring, obviously I could start from scratch in whatever package I happen to choose. But if I'm going to migrate the existing stuff, which is still preliminary draft stuff anyway, but say you've got a project, you're partway through it, and you want to migrate it. That's the situation I'm in, basically. Then I can import those files into Fusion 360, which now has the built-in electronics component, which is essentially Eagle embedded within Fusion 360. Or I could jump to KiCad and import the files into that. Now, during the week, because this is like my everyday thing, is doing board design, this is a problem that I have to solve. I need to make the decision about where I'm going in the future, what software I'm going to be using, because Eagle is doomed. Even if I got the license restored, etc., then it has a sunset on it, because it's got that in 2 years or so, I think it's going to be turned off. Yeah. So David said KiCad is pretty good. It is. Yes. So during the week I've experimented a little bit. Not with this project. I experimented with another project, actually a commercial project for a client. And what I did was took those design files so the Eagle project files, and I imported them into KiCad 7, and I imported them into Fusion 360, just to see what the process was like and how it would end up. And so both of them are good, valid paths forward that result in a very workable project that you can then continue to develop. Now, this is a real conundrum. I want to be on KiCad. It's for so many reasons. But there are some friction points. Now I want to get into actually doing this. So I'm not going to go into this. I could be talking about this for the rest of the live stream. The friction points mainly involve things like libraries. And I've got such an investment. I've got now 12 years or whatever it is of investment in creating Eagle libraries, which have been very well structured, broken down into categories, and thousands of edits on them. I've got 3D models associated with all the parts I care about. All the footprints are known good. I've fabricated boards, and I know that I can confidently run my CAM processor and generate board file, send it off, and know that everything is going to work. All the clearances are going to be good. The footprints all fit. So I have great confidence in the decade plus of development that I've put into those libraries. So starting with KiCad is going to mean jumping to a new library system. Now, there are a couple of sweeteners that work in favor of Fusion 360 and taking Eagle projects into Fusion 360. One is how seamlessly the tools work and the command line. We can't really tell from outside Autodesk whether they have re-implemented the Eagle functionality within Fusion 360 or whether they largely took the code base and migrated it. To me, it feels like they took the code base and migrated it and put a nicer UI on it, because everything works. It is quite astonishing how much you can do in Fusion 360 that it just makes me think they must have migrated it, because there are things that you can do in it that I don't think they would have bothered re-implementing. There are a whole lot of command line things that you can do. And the nice thing about that is that my Stream Deck profile, so I've got hotkeys on my Stream Deck to select tools and do all sorts of things in Eagle, like go into change mode, select a font type and change the font size. Like, that's a thing you can do as a command line input on Eagle. I can run that in Fusion 360 and it works. So I think a lot of the internals may even still be the same. The other is the libraries. I didn't even have to do anything because it's all using managed libraries on the same back end. All of my parts are there, my libraries are there, nothing has changed. So those are the smoothening things that help direct me towards using Fusion 360. And the integration with 3D. But I still want to be on KiCad. So for now, for the purposes of this project, what I'm going to do is continue it in Fusion 360, and we're going to see how that goes. However, I think for a future project, I'm going to do it in KiCad 7. So this is going to be a bit of an exploration for me, and we will see how smoothly all of this goes. Yes, so what I have done is so people have been I've been ignoring the chat for the last couple of minutes. Okay, so DIY in the Ghetto said, you need a program that can migrate it over. Not many programs can do that, some can, but might mess something up trying to import it. Yeah, well, the thing is that both KiCad and Fusion 360 can import Eagle files, and they can do it really decently. We're about to see how smoothly it happens in Fusion 360, and it's not as smooth in in KiCad, because of things like It's fundamentally a different engine, which means things like the layers have to be mapped from one to another, and there's a fair bit of messing around. It's not just a matter of open the files and it's all there. There are some steps you have to go through, but you can get your projects from Eagle or even from Fusion 360, because Fusion 360 you can export in Eagle format and then you can import into KiCad. You can get into KiCad pretty easily. It's not too much of a hurdle, so I am going to do that. Mitchell says, honestly, KiCad is probs the best. It's open source, not tied to a company that will whimsy change. Yeah. So this is all going to be a learning experience. Capistor asked a question which I'm not going to try to answer, but someone in the chat may want to. What would you recommend for a small-sized GPS tracker that I'm currently making in terms of antenna, using GNSS and GSM both? I'm kind of reluctant about the signal strength. That's not something I'm an expert on. I've done a bit of GPS work, but not a whole lot, and I'm going to leave that squirrel for other people to chase up. If you've got answers in the chat, go for it. Henrik said you could also import them into Easy EDA Pro. Yep, that's true. Dodgy. Oh, lol. Erica just said you may be her dream man. No, you're her dream man, Dodgy. She was looking at your container rack in the background. She's been trying to organize me for years. Yeah. Okay, Dodgy, what you need is a label printer. Javier says, I use KiCad. David said, you're going to have to redo those in 2 years' time anyway. Austin, yes, welcome along. All right, so without taking much more time, let's have a look at what the process is like. So what I've done is I have opened Fusion 360. You can see that I'm on the trial license again. Oh, thank you very much, Autodesk. But let's see how this goes. What I've done is created a folder called OpenKO just inside Superhouse Projects, and I'm going to go upload. So what we're going to see here is the process of being on Eagle, having a project that is partly done, and then migrating it into Fusion 360, and we will see. Oh, Henrik, yes, your super chat did arrive. Thank you very much. I appreciate that. Yeah, I need a thing like what Sion has with the background audio that goes super chat, which is a sample from who is it? The other YouTuber. I can't remember who it is. I can't remember. Yeah, Austin, they haven't... Bit loony, yes. It's a bit loony saying, super chat. No, Austin, they haven't fixed my account. They have basically just handballed it back to me and said, well, go on a trial. The two responses I've got from them. The first response was, show us the contract. It's like, what? And the second response was, well, if you want to use it, go on a trial. Okay. So part of the reason that I am really wanting to get away from this is not the software. I actually really like the software. I want to pay to continue using the software. It's that Autodesk are being such pricks about it and not trying to solve the problem. All right, so here we go. Select files. What am I going to find? Here's my... I should just drag my file selector off the screen while I do this. All right, Dropbox, brain fade. Where am I looking? Okay, in Superhouse Projects. Where is Projects? OpenKO. So once I get up to this point, I'm going to bring it back on screen again. Okay. So this is my OpenKO project, all run in GitHub. Now, one of the things that I like about KiCad is the lack of cloud dependence. And so in here, well, you can see this has got all the auto backup files. In Eagle, it keeps the files on your local file system. In Fusion 360, once I do this upload, bring it up over here. So what I did was I selected the board and the schematic files, and they've got the same name. They've got matching names, and so it has discovered that I am uploading Eagle files, and it's giving me the option of creating an electronics design. So what this is doing is taking the associated schematic and PCB and saying they are part of the same project, so link them together. And you can just upload a schematic on its own or a PCB on its own, but this is just part of the import process of how Fusion handles this to create a new project. It's the same thing as in KiCad, where you've got a project that might have other files associated with it. And Fusion 360 does the same, but it's going to auto-create the project based on these things that I've uploaded. So now if I go into, now which one? The annoying thing is that it doesn't actually show me, like I can see from the icon here that this is the schematic. That one could be the project, or is it the schematic? I don't know. And what is this one? I don't know. Let's just open one of them and see what it is. One of these should be the project that will then open everything else. Yeah, this is it. So we've got a schematic and we've got a PCB, which is a mess. They're both a mess. Oh, thanks, Cable Tie. That's a very nice offer. But yeah, I'll be fine. Yeah, the thing is that on the trial version of Fusion 360, I can do everything anyway. It's a full unrestricted, I've got access to everything. It's just that in 22 days, that's going to stop being the case. So I need to resolve the license issue with them before then, which is probably just going to be paying for a license. Yeah. Yeah, I can export out of here. So Austin said, I think the most annoying thing is loss of files. Without the account linked properly, I think that means John has lost all of his cloud saved Vision 360 projects. Yeah, no, I've got everything. It's all still here. That's the thing, is that it's my same Autodesk profile. All of my projects are here. There are heaps and heaps of projects. I'm not going to go back into the root of this because it will reveal client things as well. Now, what am I doing? Okay, so now we have a schematic and we have a PCB. So let's switch over to those tabs. Your design uses manage libraries. Okay, open manage libraries to download and use. So this is the cloud-based library manager. And what is it? Which ones need updates? None of them. So what are you lying about? Why are you saying, so somewhere in here should be all the Superhouse libraries. Here we go. So I've got, well, under two different organization profiles. So I've got, you can see here, from here down to here are all my existing libraries. And these are what I also access in Eagle. So this whole project was built using these libraries, and yeah, there's nothing to update. It thought there was. Maybe that was a residual error from importing them from Eagle. So left click and drag to define group. All right, so what we can do now, we'll get rid of the data panel so that we've got room to actually see what's going on. You know, working on this little monitor, it's like looking through a keyhole or something. I'm used to having this ridiculous ultra-wide monitor in front of me so I can see lots of things at once. All right, so this is where we got to last time. Because I couldn't create a new sheet within Eagle because my license had been suspended, I ended up putting a second sheet beside this one. But just as a, yeah, I've got a 49-inch widescreen. That's my main monitor in front of me. But but just for the live stream, I'm using this little monitor because if I try to share the 49-inch widescreen, you would see a strip across the middle of the screen, and everything would be very, very short, short but wide. Kind of the opposite of me. I don't know why I said that. What am I doing? Okay. Design Manager. This is all very reminiscent of Eagle as well. So Design Manager showing all the different different parts within it. So we can see all the parts that are in the design, and layer control errors, nothing at the moment. Place components, that's where we can pick libraries and things to do placement. That's a bit different. And everything is now grouped in Vision 360 style into subsections across the top. So we've got design, document, validate. So things like ERC is in its own section. You know, the ribbon sort of style like Microsoft switched to with Word quite a few years ago. Well, Microsoft Office in general. So it means that there is a lot less visible in terms of tools. And if you want to select things, you sometimes have to go down into a subsection. Now, a nice thing is they've got a lot of shortcuts, and all of the shortcuts are customizable, just like in KiCad. So R for creating a new net, N for name. In PCB, I think it's W, oh, what is it? W, if I go into the PCB view, then let's do, actually, I've just got to change something on here. I'm going to go to that profile. Okay, my profile didn't auto change. So I've just switched my my Stream Deck profile, so I can do rat's nest by pressing a button, press another button, and it does rip up. I can press one button, it goes into routing mode, etc. Dave, oh, okay. David asked, do you have a standard folder structure you use when you start a new project, like documentation, design, client comms, etc., not just KiCad files, if that makes sense? Yes, I do. And that is, you saw a subset of that. Let me find, oops, that's not what I want. I want this. I'll see if I can find an example for you. It varies a little because I'm not totally rigid about the structure of how I do things, but I'll find one that that might have, oh yeah, here we go. This is in, let's put it into this sort of thing. So this is pretty much what I do. So I've got a firmware directory, a hardware directory. So hardware has the design files in it. Now, one of the things I like about this is something I was alluding to earlier. KiCad, being local file based, and Eagle being local file based, means that I can maintain everything in Git, and I version control everything. So this entire project, like this whole folder, is all maintained in Git, which means I can push it to GitHub, etc. By having things cloud-based in Vision 360, it's an extra step because Vision 360 has its own built-in versioning system, but I still want to maintain all of this stuff in Git and have it all public on GitHub. So what that means is I would need to export from Vision 360 into local files and then commit them and then push them. So it's an extra step having everything in the cloud. So firmware, normally there are some different, well, yeah, there aren't normally this many folders inside firmware. This is lots of experiments, and there are things like, this was a time of flight sensor test that I was doing for the detector to tell when there is a PCB on the conveyor belt. Well, different things like testing the stepper motors, and usually there will be an actual firmware as well. So then images is all the pictures and things, like things that might be useful for documentation. and often things like, oops, it opened on the wrong screen. Often things like renders of the design, and there's a video showing the operation of the prototype of the conveyor belt. Then I have a mechanical folder, and in this case it's got lots of 3D models of things, so .3mf files that have been exported out of Fusion 360 because I was designing all the 3D printable parts for the conveyor belt. Resources is stuff that is just useful reference, things like data sheets, in this case I've got the WT32SC01 data sheet, once again opening on my main monitor and not the little one up here. So things that might be useful for references for the project I keep in there, and that includes things like photos. What is this photo? Oh, that's a very dirty picture, a picture of my very dirty Kayo pick and place machine. So this is part of a detail of a conveyor mechanism in a Kayo pick and place. So resources could be data sheets and whatever. Then I have a README, and this is always, yeah, I pretty much always have a README in Markdown format, and this one, these also have a very standard structure, but this one hasn't been filled out yet. It's kind of just a template. So it's got credits, license, all of that information. And I often also have a notes file, which is design notes and references to things that I found that might be useful. Things like links to code examples and how different things work. And if there's reasoning behind the way I design something, I stick it into either the README or probably into notes section as well. Although notes is more like a scratch pad for myself, just as a way of seeing, a way of keeping track of things so I can refer to it later. So that is kind of, and sometimes there are other folders as well, depending on the needs of the project. But that, David, hopefully that answers your question. So I have that sort of structure that I use for most of my projects. Okay. Yes. Oh, Mitchell is talking about a discount. Yes, they do, which ends tomorrow, I think. Johnny! You were game streaming on your Twitch channel. What were you game streaming? Yes. Hang on. I'm just going to grab the tissue box and keep it close. Because despite all of the medication, my nose is still running. What were you playing, Johnny? And if it wasn't one of The Last of Us's, I will be sad. Oh, Dodgy, that's a reference back to, when was it? The early, like 1990 or 1989 or something? The Here's Johnny? 1988. Somewhere like that. Here's Johnny. Oh, does anybody else remember that? Okay, what am I doing? My brain is all over the place. Okay, playing Sniper Elite 5, invading single players, trying to do their missions, so I'm using David K says, in each project I also create a folder called orders/n for each time I submit an order to a PCB fab. So orders 1 contains the first batch run, etc. for Gerber's PDFs of billing and ordering info. Private Git, not shared publicly. Yeah, cool. So I won't open it because it contains lots of commercial stuff as well. I have other folders for production purposes. I have a production files folder for Freetronics, which contains it contains the production package. So for volume production, when you're sending things off to a factory, you need to send far more than the Gerbers. And David, I'm sure you know this. They're setting up a set of production files is a huge amount of work. You need to do things like define end-of-line test procedures and packaging and all the things that tell someone how to totally create your device, whatever it happens to be. Things like enclosure information and labeling and yeah, lots and lots of stuff. So John gets off the squirrels, else he gets the hose again. Okay, Stephen. Yeah, The Shining. The Shining. The song was inspired by The Shining. All right. So, back to... yeah, it was probably like 20 minutes ago I was talking about keyboard shortcuts in here, and somehow I'm now talking about The Shining. Okay. Now, sheets. Sheet 1, sheet 2. So I've got a couple of sheets here. What I was trying to do was, when all of this went badly last week, was create this second sheet. Well, not create the second sheet. I was trying to bring that sheet in. It actually kind of makes sense to leave it here because I'm going to merge these two together. The sheet on the left is the one from this project. The sheet on the right is the one that I copied in from, what was it? The USB hub project. That's right, I was bringing in the USB hub. And then I just stuck the Vroom 32 S3 module on there. And that was pretty much the end of the game we were playing last week. Now, I also want to redo the regulator, and the microcontroller has been gutted because it did have a regular Vroom 32 module in there with the classic ESP32 in it, and I'm replacing that with the S3. Now, I've left nets in here because I'm doing this migration from one MCU to another. I left the nets in here as a reference because this is going to have to link to things like the CAN bus interface, and these I/O connections like I/O4 and I/O5, that is probably not going to be the same I/O pins that I'll use for CAN on the S3. And the Kayo serial interface, so I/O16, I/O17, RX and TX, that would have been to the classic ESP32. So I need to find the matching pins on the S3. The live stream is frozen? Really? I just saw in the chat. Oh, okay. Not according to the YouTube dashboard. Doesn't mean that it isn't frozen. Yeah, I think it's okay. Okay, so yep, all good, working, excellent. Now, one of the tasks that I need to do, and this is one of those things that can be painful and take time, and you have to be careful about it, is reallocating these pins because I'm switching from one MCU to another. Even though I'm going from an ESP32 to an ESP32, they are fundamentally different chips and their pinouts are very different. So, their I/O is very different. Okay, now I know this is getting back onto the other topic, but Johnny has made an important point, which is, made an important comment. I hate the integration of Eagle into Fusion, so I'm moving to KiCad instead, which sucks as I do pay for Fusion for my 3D printing stuff. Yeah. Now this is probably the thing. If I didn't care about 3D, I would be much quicker jumping to KiCad. But the integration of 3D in Fusion 360 is so good, and the thing is that I have to have Fusion 360 anyway for all the mechanical stuff. So, and the disconnect that you get going to KiCad plus Fusion is frustrating. Yeah, and Mitchell says, and FreeCAD really doesn't work as well as Fusion. No, I tried. The obvious equivalent is KiCad plus FreeCAD, and it's just not the same, not even in the same league as Fusion 360. So, from a 3D point of view. All right, so piezo, that's going to have to be remapped. Anyway, my point was that back here in this sheet, I've got all of these residual nets so that I can now figure out what I want to do with pinouts onto the S3. But I should probably start making this a little bit neater. That is, how am I even going to fit this in the width of the, I don't think I am. Okay, I'm just thinking about how I'm going to structure this schematic. So, oh, this is annoying that I have to manually select this. The Stream Deck is not auto-detecting that I've gone into Fusion 360. So the, come on. Does the delete tool not work? Yes, it does. Okay. So I'm just going to get rid of some of these things in here because I'm going to restructure this. Thinking about this overall, the USB hub takes up enough space that that really justifies almost a sheet to itself. So I think what I'm going to do is restructure this to move the microcontroller onto the second sheet, and I'm going to have the USB hub and the power supply section on the first sheet. Yeah, I think that's what I should do. So what I'll do here is a group select. Move that and stick that up there for now. What have I got down there? Oh, pin allocations, board profile. The pins are all wrong, but let's move that somewhere for now. We'll just stick it up there and grab these, stick it up there, and I'm going to split this net. So let's get rid of that and put some, yeah, that'll do. And then I'm going to, this is something I don't yet know because this is my first time. So I've played around with importing stuff into Fusion 360 for electronics. This is actually my first time ever doing real things in here. So I need to put a label on here. So I've got the label tool. What options do I have? Yeah, I want that style label. I want it to be 0.05, and that'll do. Stick a label there, and then a net. I'm going to stick a couple of nets coming off here, and then back to label tool, put it there, and then I want to name that net to link it, and I'll make it DP1. I can probably come up with, yes, merge those nets. I can probably come up with better names than this. So these net names are a hangover from the USB hub. So DP1, DM1 is data positive 1, data minus or negative 1. For some reason, USB tends to use P and M for positive and minus instead of positive and negative. Should be DP-DN, I think. And so it's got D plus D minus. Oh, maybe it's plus, not positive. Okay, D plus D minus. That makes a lot more sense. Blah. All right, so I've got those ports. So now we have, if we select, no, come on. I want to do a highlight. Select that. You can see that the nets are highlighted and those nets are highlighted there. So what shall we do? Will that fit if I move it now? Maybe. Let's get rid of this frame, and I'm going to try doing a group move on that and stick it. Will it fit? Stick it right about, oop, it just squeezes in. Down one, up one, that, yeah, that'll do. Okay. So now we've got the USB hub functionality in there. I could move it a little bit to the right because there's heaps of space here I can make up. Yeah, why not? All right, let's just clean that up a little bit. Move that into about there and make a new group. Can I do a, no, I can't do a lasso select. Oh well. That's one difference to Eagle. Now, what about our lonely looking little microcontroller over there? All right, so I need to redo this power supply section as well. Now, what I want to do is, before doing too much more in terms of, yeah, well, okay, the way my brain works is a little bit strange, and I tend to jump around between things. So if I, yeah, a lot of people have a very structured approach. And this is one reason that I could never get used to the way that the workflow of doing things in other CAD programs. I really liked, in the early days of Eagle, one thing that just made it work for me is the really tight coupling between the schematic and the PCB. Because the traditional way of doing it is that you design the schematic in isolation. You just sit there and draw your schematic and have no consideration whatsoever for the PCB layout. And then you get the schematic to the point where it is done, and then the net list gets, and part list, etc., gets transferred across into a different package, typically, which is done for the PCB layout. And then if you want to make a change in the schematic, you make the change in the schematic and then you resync it. So you resend your net list, etc., across to the PCB tool, which then takes the changes, and then you have to fix whatever you need to fix. But the two are essentially disconnected processes. And that was the way PCB design was done for many, many years. And Eagle had a much more tightly integrated method, which really worked for me. So in the early days of Eagle, I found that that was one of the reasons that I was quite productive with it, because what I will often do is make decisions in the schematic based on what happens on the PCB layout. And a very simple example might be pin swaps, like changing which I/O pins you are using based on the routing to get them to a connector. And that sort of thing traditionally, I mean, what I'm describing now is much more common now. So the way things like KiCad work now are much more tightly coupled. In the early days of KiCad, when I first tried it, it was very much a schematic editor and a PCB editor, and you would do like an export from the schematic editor and import that data into the PCB editor, and it was very disconnected. It's much more integrated now and works much more like the way my brain works. But what I tend to do is have partially completed schematics like this. Like we can see we're missing the entire 5-volt regulator here. There is a chunk of stuff that's going to have to go in here. I'm going to put, this did have a linear regulator in it. I'm going to change to a switch mode regulator, and none of those parts are in there right now. But I will do things like do a bit of development work on the schematic like this, and then jump to the PCB view and this is where we're going to see if changes carry over. So I'm just going to hit save. User save, yeah. So make changes on the PCB and then go back to the schematic and make changes on that. And perhaps that is a really bad way of doing things, but it's just the way I've done things. It might, it kind of looks very haphazard, and not so methodical, but that's the way it works for me. So, what have we got here? How do I get into the sheets view? Oh, sheets. Okay, so I can spin up the sheets here. Sheets appear down the bottom. So now if I wanted to move power supply, what do I want to do? No, I don't want that. Get rid of that. And just for compression purposes, I'm going to move that across to there. And this lot, I'm going to move down to this sheet and stick it on this one. Okay, so on the second sheet, now the way I normally try to structure my projects, if they're multi-sheet projects, like a multi-sheet schematic, is the first sheet will be the generic stuff. Typically the power supply and the microcontroller with things like all of its nets defined and maybe a couple of basic, well, and USB interface if there's like a regular USB interface. So those are the things that are quite generic and they're in many, many projects. They're very common. And then on secondary sheets, I put on specific things, which might be peripherals that are used in that project, motor drivers, you know, whatever it happens to be. So I don't normally push the microcontroller down to a secondary sheet, but it just so happens that in this case, the layout of this means that on the first sheet, we're going to have the power section, power supply, and the USB hub. And then the second sheet is going to have the microcontroller and the peripherals. Yeah, doesn't matter, works either way. Yeah. Yeah. Oh, David says, I like being able to edit KiCad's .sch and .pcb files in a text editor and use things like Vim macros to do mass scale search, replace on fields, etc. Yeah, I do the same in Eagle because Eagle's project files are all XML. And I also find that using git diff on Eagle projects is really useful because you can see, and it's reasonably human readable. Like if you've added some nets and things and you do a git diff on your Eagle files, it's all XML. You can just read it and see what's changed. Yeah, where was I? That's right. So the point I was making is I have been thinking a little during the week about what other things I might want to add into this. And for a little while, I thought that what would be useful is to add a driver for a nozzle tip changer, so that when the pick and place machine needs to use a different size nozzle for a particular part that needs to go on a board, it can use a tool changer to switch to a different nozzle. But I've been experimenting. During the week, I did a little experiment, and on a Kayo, it is not possible to have a tool changer without making some kind of invasive modifications to the machine. Now, it uses Kayo nozzles, but the particular nozzle holders that it uses have an O-ring. I'm going to do lots of hand wavy stuff. The nozzles basically snap in. They've got a groove around them, and there are ball bearings with an O-ring that apply pressure. So you basically just push them in and they snap into position. You pull them out and they come out. So you can just push them in with your fingers and pull them back out. You don't need any tools. but the O-ring is fairly tight, and the force that is required, so I tested this with the machine powered up and it holding its position, the Z-axis position. If I grab the nozzle and pull it, it is enough to deflect the drive mechanism inside it. And I also did a test where I lowered the nozzle as far as possible, and then I mechanically blocked it so that it couldn't move, which is what would happen if it was in a tool change mechanism. And then I tried to retract the Z-axis, which ideally should have pulled the nozzle holder out of the nozzle, other way around, but you get what I mean. And it didn't have enough power on the stepper motor to be able to do that. So that means, unless I change to a different style nozzle holder, it's not going to be possible for me to run a tool changer on the Kayo. So I'm kind of postponing that idea, and it's not such a big deal for me. I don't really mind that much. I can just leave 4 nozzles loaded, a selection of like ones that are useful for the parts that are loaded in the machine. So anyway, the result of all of that is that what I had thought of doing was adding an extra interface into this project, which is a driver for a servo motor and 2 inputs for switches, which is what I need for driving a motorized nozzle change holder. But I can't use it anyway, so I'm not going to bother putting that in. Okay. Now, David says, so this is talking about the a couple of people have been making comments about the integration between Schematic and PCB, and Stephen says if you want to make changes on the PCB and push back to the Schematic, Altium can do that. Yep. And then David said, I found that going back and forth between KiCad's eSchema tool and PCB new tool is pretty painless, making schematic changes while doing layout. Yep. So it's definitely much nicer now than whenever I was trying it in the days of KiCad 4 or 3 or something. I can't remember. It was a long time ago. And then every now and then I will use or try KiCad again, and it has improved tremendously over the years. KiCad 6 was nice. KiCad 7 is really nice. But there are other considerations. So, well, one thing that I find super useful, and I don't know if, where is that going? Okay, this is going to be kind of awkward because this little screen that I'm on is so small, but and I can only show one screen at a time on this live stream. But if I'm going to try to have 2 things visible to you at the same time. Okay. Now, on my ridiculous over-the-top 49-inch ultra-wide monitor, this works brilliantly. What I can do is be in the schematic somewhere, and if I select the view tool and click on a net, it highlights the net, but simultaneously in the PCB editor, it highlights that same track. So if I click on that, you can see that it's highlighted the track on the right. If I click the vFuse net here, it's highlighted the track on the bottom left, and it works both ways. So if I'm in the PCB editor here, you can just see the edge of this net in the schematic. It's currently green. So if I click the view tool and then I click on that, then this has now turned blue. It's highlighted the net in the schematic, and you're basically looking at 2 views of the same thing. They are very much I'll just redock that tab. They are, yeah, it's very much two views of the same thing. It's not a schematic tool and a PCB tool. They're just different windows, and it's all live. Things you do on one happen in the other. I really like that. Yeah. David says, deadpan, 49 inch isn't overkill or silly, at least when describing a monitor. Yeah. I just wish I had two of them. So at the moment I've got 49 inch monitor, and then I've got two 27 inch monitors. But the 27s are two separate monitors above. It'd be nice if that was a single 49 as well. Where was it? Okay, so tight integration. Now, where I was going with this, what is the time? 11:02. Okay, halfway through. Now that I'm getting into this, I might actually get something done today. Yes. What I was going to mention. So the reason, okay, rewinding in time about 15 minutes. One of the reasons that I like doing things like having this very tight integration between PCB and schematic is that I can mess around with things like connectors and see the physical result. So one of the things I want to achieve out of today is, even if the schematic is not actually done yet, in terms of all the pin allocations and things, I want all the parts on here, and I want connectors, because this project is going to be all about the connectors. Most projects are all about the connectors, but this one in particular. Now, this USB hub project that I pulled across, the Hacker Hub thing, this has got USB-C connectors on it, just connected up in USB 2.0 mode only, missing all of the other pins. But I want to use, the actual purpose of having these ports on the board is so I can do things like plug in a camera, or plug in a downstream, another controller, like a feeder controller by USB, like an Arduino based feeder controller. So I want to replace these with other connectors, and let's, oh come on, go back into Fusion mode. Here we go. All right, so let's add, it's enabled all the libraries, I think. I don't want all the libraries. Oh no, it hasn't. I just want the Superhouse ones. This is only some of the Superhouse ones. All right, so I've got a USB 4-pin A socket here. So I'm going to stick a couple of those down. And what will I do? Now I need to, because all these toolbars are different, I've got to relearn where things are. Modify, mirror, that's what I want. All right, I want to flip that, and I'm going to kill both these. Oh, where's the origin point? Both of these, and move these into place. So D plus, D minus. Yeah, that'll do. Stick that in there. Let's zoom in so we can see what's going on. Don't have to be so zoomed out. Now, did I just overshoot? No, I didn't. That's all right. Yeah, yeah, there will do. Okay, so let's, rather than bothering to open a library again, oh no, I've already got a ground net there, so that'll do. So what I will do is run ground pin to there. I'm going to bring the shield down to there. I'll connect the shield on the on this end directly to ground. Looks kind of weird having ground in the middle of the net there. I don't like that, so I'm going to stick that there. And I'll stick another one there and delete the original grounds. So ground in the bottom right. Then we've got VBus. Now what is that going to come from? We're going to be supplying power. Let's bring this up and terminate that there. And we'll put a label on this. So we want to supply power to downstream devices, and that is going to come off. Actually, do we have a we're going to have a 5-volt rail here, aren't we? Yes, we are, because as someone, I can't remember who, but thank you to whoever it was, pointed out last week, we need a yes, make it a 5-volt. And yeah, I'll stick another one here. We need 5 volts because I had a brain fart moment, and I was briefly talking about, yeah, get rid of that. I was briefly talking about not having a 5-volt regulator, having the power come in and just take it straight to 3.3 volts, because that's what we care about on the device itself. We've got an ESP32 that runs at 3.3 volts. And someone pointed out very correctly that we need 5 volts for the downstream devices. So when I was gutting the voltage regulator last week, that is a consideration. I don't know what I'm trying to say. All right, so what we got now are these big USB type A connectors, which we can plug downstream devices into. And if we come across here and fit everything in, I don't like this color scheme. That really does not work for me. So we've got here these, it needs a dark background on the rest of the thing, like a darker gray. I wonder if I can change that. Document, layers, outputs, attributes, no. There's probably a view, no. There's probably a way that I can set the canvas color, but I'm not going to waste time looking at that right now. All right, so we've got, no, I didn't want to move the label, I wanted to move the connector. All right, so we've got a couple of USB connectors here. What I should do is just rip up a whole lot of stuff here too, because there's, come on, why doesn't rip up work? Rip up, unroute. Why am I turning away from a microphone that is attached to me? That makes no sense. I seem to do that every time. Yeah, okay, so looking back at the chat, Stephen says, polyfuse for each USB header for external devices. Yes, good idea. I should do that, or should I? Normally that's the downstream's requirement, but to protect myself, I could do that. Yeah. Dodgy, yes, it does save spraying the keyboard. All right, now why is my unroute? Oh, that. Okay, it just picked the wrong type of unroute when I hit my little macro keypad thingy. All right, I've got all this legacy stuff from the old project hanging around. Get rid of all of. Come on, get rid of these. And yes, I know I could just drag and group and remove them all. Let's get rid of, let's just change that to open Kayo. Now, I probably should drag everything off the board to start again. But, oh yeah, that fuse. Yeah, there is a fair bit of stuff here that I probably will get rid of. fuse. Should I have a fuse? I don't think I need it. This part of this board actually came from an automotive project, because I just copied the CAN bus stuff out of another project, and that's why it's got this fuse on there. Yeah, let's. It's got a 5 amp mini blade fuse. I don't think I want a fuse. I think I am just going to link that, and it's not going to be V fuse anymore, it's V raw. Or maybe it could be called V in. That would be more traditional. So what is this one? That is screw terminal. Okay. And this one is, what is that one? Oh, that's an XT60 connector. Do I want an XT60 connector? I'm thinking probably not. David says, no fuses, YOLO, yeah. Now, the thing is that that part of the project came from an automotive thing that was driving motors and doing high power stuff. And this is more of a, yeah, it's a lower powered type project. What was that? Info command is editing your file. We'll try again later. Creating a recovery file has failed. Oh, you can't see this because my face is in the way. Down here, it just came up with 1 errors. Creating a recovery file has failed because the info command is editing your file. Open KOV2. We'll try again later. You may want to save your document now. Why bother telling me that? Just, annoying. Okay. Austin says, considering these are moving parts on the machine, yeah, I'd use fuses on the USB ports to be safe. And Stephen says, putting a poly on the individual USB ports prevents the downstream device from shorting out your 5-volt rail and taking everything else out if the plug or cable is damaged. Yeah, okay. You make a compelling argument. So, let's do it. We'll get rid of that net and yeah, what the hell, that one and that one. Let's just move these out of the way and add okay, it's only showing me a subset of my libraries. So where are the other ones? Open Library Manager. Yes, let's do that, because I should have a whole lot of, so Superhouse fuses. Oh, this is the use column. Okay, I'm just going to turn all these on. Jumpers, inductors, modules, oscillators, yes, sensors. I want it all. All of the Superhouse test. Yep. I want all of the Superhouse libraries in use, so they should now all be synced. That's better. Okay, so now, here we go. Fuses. What fuse? I want to stick on a MOV. No, I don't. I want to stick on a polyfuse. And what am I going to use? An 1812 polyfuse. Which one is the most recent footprint? Why are there three? Oh, okay, no, these are just different current ratings. There's the old 1206 that I used to use, 150, 050. Yeah, there's actually no... The only difference, the reason there are these multiple footprints is they have different current ratings on them. So it doesn't matter which one you pick. Let's just pick the first one and stick a fuse in there. And we're going to stick a fuse up here. And how are we going to arrange this to make it moderately neat? There and there, that'll do. So we're going to come into the fuse, out of the fuse, and oop, I got that position a bit messed up. Let's move that over there. And I should set a rating on... Oh, that's going to get in the way. That's annoying. Oh well. Come on, move. Ah, I just realized one thing I'm missing is my huge cursor. In Eagle, I'm used to having a cursor that goes across the entire screen. It's a crosshair, and it extends to the top and bottom and left and right of the screen. It's not just a little cross. And that is really handy when you're lining things up on a grid. For example, if I grab this fuse and move it around, and I want to align it with this fuse down here, with the huge crosshairs, you can go, and the crosshair will extend. The crosshair will extend all the way down and let you align it perfectly with the other part below it. And I'm missing that. Maybe I can turn that option on in Fusion 360 as well. I don't know. Maybe, maybe not. But I think my effort is probably going to be best spent learning about KiCad. Right. Extreme engineering, defying life without fuses. Yeah. Ooh. What am I missing in the chat? Check video, I want it all. Pouring coffee and I wear glasses. Polyfuse costing seems like cheap insurance. Yep, okay. Cool, as you were. Keep chatting among yourselves. So, what have we got now? Our new state of affairs. Let's bring that down a little bit. Just to... Oh, that's an improvement. I just noticed something different about the way this behaves compared to Eagle. If I grab this part, this fuse, and I drag it down, notice that the nets on the side of it are staying horizontal, which is nice. Now, I know there was a retain angles option in Eagle, but it didn't have quite this same behavior. What would happen is that you would drag it down and you would end up with the nets going at funny angles, like at 45-degree angles. They wouldn't maintain this. Now, let's see if I turn off angle retention mode and then I try the same thing. Yeah, that was the default behavior, like this. This is what used to happen in Eagle by default. And then you'd have to, like you'd do that, and then you would grab this point and then move it down. It's very annoying. So it's, yeah, like that. So I want to keep it in angle retention mode, which is nicer. And bring this down. All right, so we've got our USB. Now what is going on with... Okay, so we don't quite have the USB locked away yet. Oh, excuse me. So I need to make sure that I don't put the Raspberry Pi bug in here. So I need to add a couple of 5.1K pull downs. What am I going to use? Resistors, resistor 0603, that'll do. That'll do, donkey, that will do. Stick a couple in here. Should have just done one and given it a value. Okay, 5K1 and 5X1. Yeah, 5X1 resistor, 5K. Why am I pressing X instead of 1? I blame the Codrel. All right, 5K1 resistor, and where? About there. About there. Let's stick a ground under each one and do a net from CC2 and CC1, and that will signal to upstream devices that we are in USB 2.0 mode with 500 milliamps required. Please, thank you very much. So that we can power it from the upstream port. Now, this gets into an important question, which is, what are we going to do about VBus? So this is power coming in from the upstream device. Because we have an upstream connection here to the computer, we are being a hub, and we are then supplying power down to two downstream devices. The simple approach here, and the one that would probably work most of the time, is just to stick this VBus connection straight into the 5-volt rail. But sometimes it won't work. I also don't want to back power this. So, oh, there's some, these need to be fixed up a bit. These labels and things are a little bit horrible, and the value doesn't even say the unit, it just says 30. That'll actually be a 30 ohm resistor, and although we probably don't even need them. Yeah, that's not nice at all. Anyway, where was I? That's right. So we are probably going to have to supply power. We've got this external power input up here, and that is going to be, so the thing is, I could do away with this entirely. I could remove this whole 5-volt regulator and simply, I could basically do this. I'll actually do it just to show you what I'm talking about. I could take the 5-volt rail and go, yes, that is now the 5-volt rail, and delete everything left of this 5-volt thing. And then what would happen is power would come in from the upstream USB. We'd get 5 volts coming in, and it would go into our 3.3 volt regulator and power the board. It would also go to our two downstream USB devices. But I don't think that is a great way to do it, because it's expecting that the upstream device is just going to provide lots of power, and that's how unpowered USB hubs work. It's probably all right, but I'm thinking about if there is something like a camera plugged into one of these ports, it's going to pull a bit of current. Cameras can take several hundred milliamps, and we might be pushing what the upstream USB port can supply. So as a minimal design, I would do what I am doing here, what I'm showing here, and delete all of this. What have I missed? Okay. Wagon Load says, my 6-port USB hub is an LED on each port. Stephen P says, P-channel FET as near ideal diode. And Wagon Load says, I usually put resistor values inside the resistor body. Yeah, that's a good one. Johnny says, 2 webcams is probably like 700 milliamp. Yeah, I don't expect to be running 2 webcams off this, because partly for bandwidth reasons. This is all USB 2.0, and feeding 2 webcams through this is probably, and into this hub and then into a single USB port, is probably not a great idea. I think these downstream ports are more useful for things like connecting a feeder controller that is just going to be expecting G-code over a USB serial interface. So we're not really supplying a lot of power through them. So my expectation is I'm probably going to plug in a feeder controller into one of them, and maybe a camera into the other. So I'll probably have one camera and a feeder controller, although I may end up with 0 cameras. So, don't know. What about a separate regulator on each output port? No, I don't think I need it. I think that would be overkill. So what's going on in my head right now is I am mentally debating what to do about this power situation. And whether... I'm actually questioning this now. I am questioning whether I even want an external power in, or if I should just make this like a self-powered hub that is powered from the upstream device. But that's really pushing it, because we do have an ESP32 on here, and these things can suck juice hard on startup in particular. Like if they fire up their radio and do Wi-Fi calibration at startup, they can pull hundreds of milliamps briefly. Oh, and we've got CAN buses. Well, you're right. Okay, I'm glad I clicked through to here. This helps clarify things. All right, now, CAN bus, that's the thing that I have not really mentioned this stream. This is an important consideration. The way I normally do CAN bus is I typically send 12 volts along with the signal. So most commonly I use like a 4-wire cable so that I've got ground. It says V raw here, but I typically pass 12 volts. In fact, maybe I'll explicitly make that 12 volts. I think I will. Austin says, could use one of the ports attached to a CH340 to the ESP for built-in programming. I don't actually need that because the ESP S3 does programming over its own native port. Wagon Load says, can you have a current sensor turn on external power on demand? I could, possibly. Now, what was I doing with this? Oh, that's right. So let's do something different. Add supply symbols. I'm going to stick a 12 volt supply symbol joink right there. Yes. And get rid of that little stub and the label. All right. Move this down a bit. So this is my typical arrangement. I'll bring that down a little bit just to be neater. Come on, move down there. So this is my typical arrangement when I am connecting devices together. This is what I did on the wheelchair projects with Chris. So on the wheelchair hand heater, for example, on the control interface, like on our wheelchair motor controller that had a CAN bus interface, what we did was have a 4-wire connector, and we had ground, power, CAN high and CAN low. And although in the case of the wheelchair it was 24 volts, not 12. And this is also what we do on the water cannon project. We have a cable like this, and it means that you can power devices on the bus by just plugging into the bus, because you've got that available right there. So I kind of like it as a convenience thing. The reason I'm waffling on about this is directly related to the decisions to be made about the power supply stuff here, because we may want to use this device as the power source for other things on the CAN bus network, such as the conveyor belts. So if the conveyor belts are running on 12 volts, they plug into the CAN bus. It would be nice if they got their power from it as well, and we didn't have to plug a separate power supply into the conveyor belt. So the power that we supply here ideally should also run everything else. Now let's should I fuse that? Ooh, I probably should. Okay, because at this point we're not talking about digital logic level stuff. We're now talking about 12 volts potentially at amps for running motors and other things downstream. So I think I am going to Stephen says 12 volt to 5 volt buck, 5 volt to 3 volt linear. Yes, that's exactly what I'm doing. That's why I deleted the linear regulator that was here. I'm going to put an LMR3 8010 in there as my 5 volt regulator. I will get to that in a moment, I hope. Wagon Loads said, can it use a laptop power supply for power input? Laptop power supplies are typically around 19 volts, I think, from memory, which is a bit of an odd number, but that just happens to be the way it works out for the battery packs that are typically used in laptops. So, yes, outside the box says, had to reboot, catching up. Mitchell says outside, said, my condolences. Yes, please accept our condolences in this difficult time that you're going through, Chip. All right, now I'm going to be a bit more explicit about this. What I'm going to do is say that this is 12 volts in. I'm going to make the decision at this point, right now, that the input is at 12 volts. And that is then going to be passed through to other devices on the bus. And this device here is going to be just one of those devices on the bus. All right, so, okay, it's starting to form a plan in my head. This is what I'm going to do. I'm going to grab a fuse. I'm going to get a, what type? Not that one. That one. Yes, that one. This is an automotive mini blade fuse, and I'm going to give it a value of, yeah, let's say 5 amps. That'll do. I think that's pretty much the lowest value that you can get little automotive fuses. So what we're going to have is a value, we're going to have power in here. This is going to be our VRAW, so let's bring that in. Then we are going to, in fact, what I'll do is put a note on that. V in is 12 volts. I'm just thinking about the annotation side of this. Let's get rid of that and that. And we'll change this just to explicitly say 12 volts nominal. We'll just move it up out of the way for now. Move the label up out of the way. Bring this. Do that. And link this to here. All right, so we've got VRAW. What do I call it? VRAW, yeah. That'll do. It's just the power that comes in before fusing or regulation or anything else. Could be V in, but I'm going to use VRAW voltage as the label. So, oh, that's interesting. That's another difference in behavior. Oh, look at that. That's nice. Yeah, the part move behavior is much more elegant now in Fission than it was in Eagle. Previously, if I grabbed this and moved it left, it would have moved it on the net, and the end of the net would have got shorter on the left. The label would have stayed in the same place. Okay, so maybe I do want an XT60 connector. Kind of tempted to have both. I don't know. All right, I'm going to move the XT60 out of the way for now. I really like XT60 connectors. Oh, do I? Don't I? I don't know. Okay, for now I'm not going to. I'm just going to use the pluggable terminal block. I don't know which way around this is going to be, but that can be resolved later. Okay, so people are asking why not use the XT connector, and David wants to know what is the issue with it that I'm conflicted over. The size of it, and that it's kind of a slightly uncommon thing. I use it as power all over the place. I love it as a connector. But yeah, a little pluggable screw terminal is probably more universal and just not populated. Yeah. Thanks, Mitchell. Well done on the pause. I timed my cough well, pressing the cough button. Now, thinking through the logic here. What do we want? So we've got a, well, maybe the, now that is 18404. No, let's make that a, make that an SS56 shot tree. Yeah. Oh, I can't speak. Instead of a basic silicon diode, like a 1N4004, this is just a polarity protection thing. And I'm just wondering whether I should put protection on before we feed out to other things. But that is then going to put all of the current through that diode, and it's going to cause a slight voltage drop. So if I use a Schottky diode, yeah, it's probably okay. As someone mentioned earlier, I could use a PFET or something as a close to yeah, as a close to ideal diode. Now, Cable Tie says, for a permanently connected device, the pluggable screw is probably better. Yep. Wagon Load said, how common are barrel jacks? Pretty common. Stephen says, a single 4-pin pluggable terminal could do power and CAN all in the one plug. Yeah, that's what, exactly. That's what I'm going to do for the connections to the CAN bus. But this is for the power coming into this device. So the CAN bus here, whoop, that connector right there, this is the one that I'm going to use for passing to other devices. And it includes ground, power, and CAN in a single connector. That is a 4-pin pluggable screw terminal, which is a standard thing that I use on many CAN bus projects. I also use M8 connectors, which are little barrel connectors, and they're environmentally pretty good. I mean, in terms of being able to work in nasty environments, and they've got a screw collar on them so that they mechanically lock in place and you can't pull them out accidentally, which is good for things that are moving, like on wheelchair projects. I use the little M80 connectors for CAN bus and power. But on fixed position projects like this, pluggable screw terminals are just a generally more convenient thing. So this is what the CAN bus is going to look like going between the devices. But what we're talking about at this point is power coming into this device from some external power supply, which is then going to be delivered to the CAN bus. Okay. Cable Tie says, this is in relation to the DC jack. Common but not good for permanent install either. Yeah, so one thing to keep in mind is that what I'm working on here is a board that is going to go inside a pick and place machine, and it's an industrial install. So it's not like it's going to be sitting out on a bench with things plugged into it. It's going to be inside the chassis of the machine. And industrial machines are typically wired up to sorry, I just saw something I'll get back to in a second. If you look inside a piece of industrial equipment, they are often wired kind of like a house in some ways. They have DIN rails inside them and plug-in modules and permanent wiring into screw terminals and all of that sort of stuff. So they don't typically have plugs and sockets in what you would think of as a consumer sense. They have things like, they can have things like pluggable screw terminals just for convenience of maintenance, but it's more like a permanent installation with modules wired permanently together than things that are Mitchell says to drink my coffee. Yeah, and David says industrial machines, when things go wrong, they really go wrong. Yeah, and they go really wrong really fast. Wagon Loads asked, will ESP control anything regarding power distribution or putting data into the USB data stream? It will, I'm not quite sure what that question means. Regarding power distribution, no. The power is just going to be passed to other devices that might want to consume it. And putting data into the USB data stream, yes it will, because it'll be receiving G-code commands from OpenPnP. So the purpose of this board is it's going to sit between a host computer running OpenPnP and the Kayo machine. It takes G-code coming in over the USB serial port, converts it into the Kayo's internal binary protocol, and then sends it out to the Kayo and gets responses from the Kayo, converts it back to G-code. Stephen says it will participate in the USB, but it doesn't control the data stream. Yeah. Oh, okay. So maybe, yeah. Okay. Maybe I didn't quite interpret the question correctly. Yeah. It doesn't. It's not going to have any control over what these other devices do. It is just another device on the thing. So if you look at the logic of this part of it, it's kind of laid, come on. It's kind of laid out here. We've got the upstream port here on the left. This will go to a PC, probably in my case running Ubuntu, and with OpenPnP running on it. So communications comes in on the upstream port. The USB hub then has 3 devices downstream of it. One of those devices is the protocol converter. Another device could be a USB camera, and another device could be a feeder controller. So each of those 3 downstream devices is independent. This is just a convenient way of having those extra devices plugged in, and we've only got one USB connection to the upstream device. So it's kind of, I mean, all of this could have been done just by using an external USB hub and not have any of this at all. Just have 3 separate devices plugged into USB hub. But I'm doing this just because I kind of can. I'm integrating the hub into the device directly so that you plug one thing into upstream and you get all of these devices, including us, the protocol converter. So, all right, back to power. We've got VRAW coming in and going through a fuse. Then locally we've got a protection diode. These things are rated, well, yeah, the SS56 is rated to 5 amps anyway. Partly what I'm doing with this is protecting ourselves, from whatever is going on the rest of the CAN bus, other devices that are using this power. So I kind of don't want to get in between those other CAN bus devices and the power source. Other than fusing it, I don't want to be interacting with them or influenced by them in any way. So I think having a protection diode on the inside of this is okay. Okay. Now, yes, Kim has a broken caps lock, or Kim is a bot. Now, or was there an actual question in there? I'm not sure. What am I doing? All right, so we're clarifying my thoughts about power and explaining what's going on in my very addled brain. Okay, so V raw, 12 volts, comes in, dunk, 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 and then it goes off to 12 volts. Is that, let's do this. Let's explicitly add that 12 volt symbol there. So we are now, so that is the 12 volt net, and that is fused but nothing else, and it then passes to the downstream CAN bus devices. We are protected from it by this diode, and then we come into our own regulator. Okay, I think that's a reasonable, there's no power switch or anything on this. The way I see this, downstream devices can look after themselves. That's their own problem. All we are doing as a convenience thing is passing power to them, and we are fusing it locally just in case one of them screws up and shorts to ground. We don't want to blow our own power supply. Yeah. So, all right. Screw terminal or XT60. Now, as much as I like the XT60, cable tie is correct in that as a permanent installation, this is not quite the same thing. So, I think I'm going to do it. I've selected the delete tool. I'm going to zoom in. Here we go. Bang. XT60 is gone. Okay, so we have a screw terminal. I need to work out which way around I want that. What's the polarity on the screw terminal? There is a standard way that I do it. So, in fact, I've got one of those cables right here. And I need to figure out which way around does this connector go. So the key is on the top. Sorry, I've got a cable here. This is a standard way that I do pluggable power on those 3.8 1mm screw terminals. In fact, this is an XT60 to screw terminal cable. So this would achieve exactly the same result as putting an XT60 connector on the board. But anyway, the point is, because I use XT60 for everything on my lab power supplies, and I've got cables and robots and things, all XT60. Okay, so pluggable terminal and power. Now, I have positive on the right and negative on the left when I'm looking at this from the top with the key on the top. So what I need to figure out is which one of these is which. Okay, I can do that in here. Now, where did it go? Where is that thing? There it is. Here's the connector. I'm just going to move it over to here. and ground is on pin 1. I believe this is actually, I did it backwards. So I want ground, oh no I didn't. Oh yes I did, yeah. I've got it on backwards. Alright, so what I should do is go back to here, and I'm going to do delete, delete, and grab that, rotate it. Where is the edit? Where? No, come on. Where is the move? Oh, it'll be here. Modify, mirror. There we go. I've got to relearn where all of these tools are. All right, I'm going to put that back in here. Put that net onto there, that net onto there. Okay, so now on the connector, I'm just comparing this to the actual physical thing. So, oh, and it's backwards from the point of view of looking at it. So if I just grab that and turn it around, this is looking at the pluggable screw terminal. Imagine the edge of the PCB is here, and then we are plugging in from below. So ground is on the left, positive is on the right, and that is correct. I mean, that's totally arbitrary. The only reason I'm doing that is for consistency with other things I've done with cables like this, so I can just plug them in and it'll work. Okay. I'm just going to hit save because I'm paranoid. Okay, so power comes in, goes to there. It's 11:53. What I really want to do is have all of the parts in this schematic by the end of this live stream. So what I had wanted to do was put all of the connectors approximately in place, but that ain't gonna happen. So I need to bring in a regulator to go in here. Now, the way I would do this, oh, this is going to be another learning experience. The way I would do this in Eagle is I would open an existing project that used that, and I would copy that part of the schematic and just bring it in here. Yeah. Ooh. So that's going to mean importing a project into Fusion. Do I have any? Actually I do, but it's a client project, so I can't show you. Okay, so let's get rid of the double me. Even one is too much. You don't need two. So I'm going to go, without showing the screen, I'm going to go into a client project and I'm going to do an experiment. What I'll do is open the schematic, Inception, yeah. I am opening the schematic of a project that uses the regulator that I want to use. And where are we? I'm going to copy just part of that schematic. And that's that, and that. Blah, blah, blah. I'm just memorizing other things that are around it as well, because I'm going to re-implement that. 5 minutes to lunch, says Amanda. Thanks for the reminder. All right. Now, I have no idea if this is going to work. Well, actually, I am going to show you this. So this is because it's not going to reveal things that you shouldn't see. This is in a client project, but it's only a small portion of the project. So I'm going to go back to this view, and what I've got here is just part of the power supply of this project. And this is another project that actually happens to use CAN bus, which seems to be my life these days. So I want to take this LMR 38010 switch mode regulator, this part of the circuit, and move it into our other project. Now one thing that's nice is you can see across the tabs at the top here, I have got these projects open at the same time. I couldn't do that in Eagle. I often would open 2 copies of Eagle simultaneously to have 2 projects open, but it would get very confusing. So let's go to group. I'm going to take that portion of the schematic and I'm going to go copy group. All right, so I've got this part of the schematic in the clipboard. Now, if I go to the open Kayo, which one is it? The schematic here. I'm going to zoom up here a bit so I've got some clear space. Now, can I do paste? Is this going to work? It doesn't look like it is. Oh, paste. Does that work? Yes, it does. Boom. Okay. Now, it won't have copied across the layout or anything, but that part of the schematic at least has been copied across. All right. So that is meant to be the ground rail. It's probably not even connected to ground at the moment. No, it's not. Ground 1. To avoid the conflicting NAT classes, it's renamed it to ground 1. All right, so I want to jam that into this part of the schematic here. So, which way? There, okay. One thing I really don't like about, okay, so in Eagle, you can pan easily by just clicking with 2 fingers and then dragging. I'm doing that right now and nothing is happening. So to move around the schematic, you have to like move your cursor and zoom in and out to get to where you want to be. And I hate that. There must be a keyboard shortcut that lets you just grab the canvas and drag it around without zooming. This is the way that KiCad seems to work too, and it drives me nuts. Now in the PCB, if I zoom right in like this, that's with 2 fingers. I can grab this and just move it around, which is what I want. I want to be able to just pan around the canvas. Works on the PCB, doesn't work in the schematic. Frustrating. All right, now what am I going to do? Make a little bit of space here. I've got border boxes around. Border boxes around part of this. I'm just going to do some moves. I'm going to do some compressing. Move that across to there. Move that across a bit more. Give myself plenty of space to work with in the middle, and then it can all be re-optimized later. Bring that across. A little bit more compression. Just a little bit more. And there. That should be close to giving me enough room to bring in what I want. All right, so now there was a comment earlier about reducing the voltage on these caps to save some space on the board. That is a very valid point. Now, this is a squirrel to chase, but I'll chase it just briefly. These are electrolytic capacitors, which are good for bulk capacitors on power supplies and things. In this schematic, it says 330 microfarad, 35 volts. And typically what you do is overspec the voltage based on what voltage you're going to run them at. Normally by about 50% to be safe. Which means if we're feeding 12 volts in on this, see, I'm zooming in and out to move to different parts of the canvas. Has someone given me a solution for that? Middle mouse button. I don't actually have a mouse. Nope, I've just double clicked. Like I've clicked with the 2 buttons at the same time and it's not doing anything. Yeah, I haven't used a mouse for about 15 years. I've got a trackball because I developed really bad carpal tunnel syndrome on my left hand. So I switched to using a trackball on my right hand. No, not 15 years. Oh, it's close. Yeah. So my input devices, I have a trackpad on my left hand, a trackball on my right hand, and I've got a space mouse in the middle. Can you drag with 2 fingers? No. Doesn't work in the schematic. It works in the PCB. That's dragging with 2 fingers. In the schematic, doesn't do a thing. Okay, so back to capacitor voltages. So, what was I saying? That's right, 50% derating on capacitors. So 12 volts, and then 50% of 12 is 6. Therefore, we need capacitors that are rated to 18 volts or better. And a typical electrolytic rating, so what you do is you add 50% to your operating voltage, which gives us the 18 volts, and then you go to the next value that is available, and typically that would be like a 25 volt electrolytic. And the physical size of capacitors is a function of both the capacitance and the voltage rating. So the same capacitance in a 25 volt capacitor would be physically smaller. So that is a very valid point that was made earlier. To save space on the board, I could go for, say, 25 volt capacitors. Now, I'm not going to do that because of commonality of bill of materials. So I've got, in fact, this here. Nope, I don't want that. I want that. I'm going to make this 220 microfarad, 35 volts, because that is, and I think there might be another one over here. Yeah, there is. And that one, I'm going to make that 220 microfarad, 35 volts. Reason is, I buy these caps, those 220 microfarad 35 volt, by the 1,000. And I use them for other projects that require that higher voltage rating. And so I already have them. It's not optimal for this situation. I could specify 220 microfarad 25 volt or a 330 microfarad or whatever, but this way I already have all of that stuff ready to go. So I know that I'm over time, but I'm going to keep going just for a little bit because I want to get this schematic, get the power supply portion of this schematic done at least. And from that, the schematic is very close to done apart from pin assignments on the vroom module. So what am I doing? That's right. I am zooming in on here and I'm going to move this way over here out of the way. I'll just drag these out of the way. You can probably hear my stomach grumbling. It's going crazy. What am I going to do? I'll move. Ooh, that's interesting. What is going on there? All right, I want that to still be ground. I'll get rid of that, get rid of that. I can probably, what am I doing? I'm just moving stuff around. All right, I'll move that off to the edge. I'll move this off to here. I'm just going to jam them up and make myself some space for now. And then I'm going to clean it up once I've moved this other thing into place. So that's going to be the new ground rail. That is going to be the VN. That's going to be the 5 volt. So I should now be able to mostly fit this in. And it's going to be a tight fit, initially at least. Right about there. And then I will join the output into the 5 volt net, and I'll join, because that coincides with this, I'm just going to move it off there to disambiguate the selection. So there, VN plus, okay. And that needs to become ground, so that can join into there. turn ground 1 into ground. Yes. Can I save myself some vertical space, which would be actually quite useful at this point. Let's bring this up a little. Bring that up a little. Bring that up a little. That doesn't need to come up. I'll bring that up to there. And bring that up to there. And then I can make all of this neater, I think. So, bring that up. Okay. Getting closer. Still a bit of a mess, but it's getting closer. So that ground I can pass through to there. Because we're passing the border of a logical block, the way I normally do this, no, it's not 12 to 24 volts input, let's get rid of that. The way I normally do this is when I have logical blocks in a schematic, like this chunk here, power in, it'll have grounds within it, and then there'll be signals that pass between them, but the grounds are in their own blocks. So, I wonder if there's an example here. No, not really. Anyway, doesn't matter. So what I could do is just run these ground nets through and make it all one trace that runs all the way along here, but I tend to keep them separate. So I'm going to move that to there, and in fact what I'm going to do is put, similar to what I did earlier, I'm going to stick the ground on the right hand side, so it's like the entry on the top left, exit on the bottom right in terms of current flow. So I need to make myself some more space there, and that little stub I'll get rid of. Yeah, it's not very neat yet, but it's starting to get there in terms of being logically correct, if not aesthetically correct. So then I'll bring that down to a line there. Ideally I want the bottom of all of these logical blocks to be aligned as well visually. So I could gain a little bit more space. And oh, I don't like that. Let's bring that down to there and get rid of that. That looks nicer. So we've got signal path coming in here in the top left, which is just the voltage power supply. Then going out, I can move that in closer, which gives us a little bit more room. I need some more capacitance in here, but I can add that. All right, so we've got bulk capacitance, and we've got a little electrolytic, and on the output side we've got some bulk capacitance and a little electrolytic. That's okay. I could probably add a few more of these electrodes. In fact, what I could probably do is get rid of this electrode and put a few ceramics in there in a little parallel matrix. Oh, my stomach is grumbling. Okay, move that down, move that down, move this down. This is what I was talking about earlier. I want to make visually the ground rails aligned between these two nets in the schematic. So you can see that there is a logical flow through in the power on this top side, and there is a logical alignment with the ground on the bottom side. Oh, there's a fair bit of space we can gain over here too. We can, oh, come on. We can move that to there, which means we can then drag the whole thing across. We can take this block and move this group across to here, which then gains a space here, and we can start to make things look neater. Now if I move, let's just butt that down. Yeah, I'm not a fan of that. I like to see a net in between But what this does is allow us to, one more, okay. Bring that down to there, and I'm going to join across here and then get rid of these ground symbols. All right, so now we have some logical blocks. We have power in, which is going through a fuse. Why do I have that tag coming off there? That is not really a great layout. Okay, oh, I know why. It's just legacy of the way this kind of came about. Let's move that. So I'll stick this here. VRAW. I'll stick that down there. And I'm going to run a net, a stub net to nowhere, just like that. So that is an indication of, let's move this. I need to put these designators on nicer spacings as well. All right. Yeah, okay. Power comes in. That's just an annotation net there, no other reason for it. Then goes through a 5 amp fuse. From 5 amp fuse it becomes our 12 volt rail. The 12 volt rail is used for downstream CAN devices. It passes through the diode for protection of ourselves, and we then have some bulk capacitance feeding into a switch mode regulator, which will give us 5 volts out. We then have our 5 volt rail passing into the 3.3 volt regulator, which gives us, I don't even know why that note is there. Another cough. That's the max rating on the switch mode regulator. No, the linear regulator. Oh, excuse me. I'm going to need a rest after this. All right, so we then have our 3.3 volt rail. Could probably do with a little bit more capacitance on here, but we're not doing too badly. We've got bulk cap and ceramic, bulk cap and ceramic, bulk cap and ceramic on each of the 3 voltage domains. One is the raw side, the input into the 5 volt regulator. One is the 5 volt rail, and one is the 3.3 volt rail. So I think our power supply section is not looking half bad at the moment. It's that'll probably do what we want. Cool. Alrighty then. Next thing is, hang on, where is the zoom? Oh, there it goes. There it is, the zoom to fit. All right, now microcontroller, I'm going to move this onto the other sheet. So we'll expose the sheets, grab this group and move, yes, move group, and I'll stick it onto this sheet, where, anywhere, doesn't matter, there will do. All right, that's just nets for reminder purposes. So now we have the first sheet in not too bad shape. We've got, just for consistency, I'm going to move that, come on, move that label down a bit closer, move that label down a bit closer. So we've got our 3 downstream USB ports here from the hub. We've got the hub chip, which is connected to the 3.3 volt rail, and I always like to check this visually. I just want to see it for myself. So if I double click the 3.3 volt rail, we can see that it's highlighted VCC going into the hub chip. We can see that it's highlighted the output of the 3.3 volt regulator, so we know that net is connected. It's highlighted the the output enable into the clock. So that's all looking good. Looking good. I think the first sheet is probably in decent shape. Second sheet. All right, we've got the ESP32S3, CAN bus interface, Kayo serial interface, and piezo beeper. So the remaining task here is just the connections onto the S3. So there are some really, really obvious things like, oh, that's not the tool I wanted. I wanted the copy tool, that one. Like, let's stick a ground into it, and let's stick a 3.3 volt. No, move that up, and put a net through to there, and put a net. Hang on. I'm two-finger dragging. How is it that when I was trying this before, I could not pan in the schematic with two-finger dragging? Like, I was sitting here with two fingers on the trackpad moving it and it would not move. And now it's working. Is it just different modes? Like, depending on the tools I've got selected? That is weird. I mean, this is what I want. I was just doing it without even thinking about it, and I didn't even realize that it was working. Huh, cool. All right, so we've got the USB connections going to the first port on the USB hub. We've got power. We're going to need to connect a few things. I'm going to connect a boot mode button, even though technically on the S3 you don't need it. GPIO 0 is a strapping pin on the ESP32, and if the microcontroller gets into a situation where it can't boot properly, like it can't accept new uploads, having a way to pull that low is probably useful. All right, so reset. Stuff we can transplant from here. Oh yeah, I should put a 10 microfarad cap right there, shouldn't I? So let's liberate this cap, and we'll move that and stick it down here somewhere. I'll take that up there. How am I going to do this in a neat way? I don't think there really is a neat way. It's going to be ugly no matter what I do. Let's do this. Oh, so ugly. I don't know if I can bring myself to do it like this. But anyway, I'm going to start like this, and then my shame is going to make me redo it later. Okay. Oh, look at that little loop. Can't stand it. That's just signifying, effectively, that capacitor is exactly the same as if we had stuck it here alongside C5. It's just two 10 microfarad capacitors in parallel because they're both connected to 3.3 volts and ground. And in the schematic, I could simply move it to here, and that would be electrically exactly the same thing. But ideally, on the PCB, we want this capacitor to be mounted right next to the 3.3 volt pin going into the MCU. So there are a couple of ways to show that. One is what I've done here, which is physically, not physically, in the schematic, put the capacitor near the power supply pin, and that then indicates to the person, maybe yourself, maybe someone else, that when the PCB layout is being done, that capacitor should be associated with this power pin. The other is just to put a note next to it. So it could be back in this location with a note saying locate C6 near MCU VCC or something. And then you would know to do that when laying out the PCB. But I kind of prefer representing it in the schematic by putting it near the thing that it is doing the thing for. I don't know why, that's just me. All right. Yes. Oh, okay. I have been failing to pay attention to the chat. There are some interesting questions further back about the power supply stuff. Okay, so so there was a question about using. I haven't scrolled back far enough yet. Right. Search a whole lot of stuff about Windows. Okay, so questions about power supply, about whether to use a drop. So, okay, there were questions about using linear versus switch mode supplies and whether to take from the 12 volt directly to 3.3 independently of the 5 volts. Because with this current arrangement, right here, what we can see is we've got 12 volts coming in on the left, gets regulated here down to 5 volts, then that 5 volts goes into this regulator and gets regulated down to 3.3 volts. So the alternative is that you have two independent regulators both feeding off the source here. Now the advantage, there are advantages and disadvantages to both approaches. If you're using switch mode regulators in both cases, then that may be fine. Because what's happening here is that we are putting load on the 5 volt regulator with all the power that we are consuming in the device here at 3.3 volts. So whatever we need at 3.3 volts, which could be a couple of hundred milliamps, that has to be supplied by the 5 volt regulator. Which potentially is reducing the overhead or the amount of current that is available for other things that need the 5 volts directly. And you avoid that problem by supplying the secondary regulator directly off. However, this is a linear regulator, and dropping, and in fact, it's, what is it, an APK 2112, I think is what I generally use. I don't know why that doesn't have the part number on it. That's odd. Let's see, value, I'm just going to stick it in there. Do I want to change it? Yes. APK, oh, it's already there. So why is it not showing? I think I need to do a relocate attributes command or something. Is that in here? Edit, view. These menus are broken. Like, I'm clicking on it and it, oh, now it's working. Weird. Bugs. All right, where is the attributes thing? And assuming that it even exists in Fusion 360, it may not. There is a reposition attributes command in Eagle, but I'm just assuming that it's going to be here somewhere. Maybe not. What I could do is just go into the command and go reposition. Yes. Okay, reposition. That, it worked. Amazing. Total guess. So reposition attributes from the command line worked, even though I couldn't find the tool. Okay, so back to this power supply question. Now, the AP2112K linear regulator has a maximum input of about 6 volts, which means that we couldn't supply it off this 12 volt input anyway. But even if we had a regulator here that was capable of taking 12 volts in, and it was a linear regulator, it'd get pretty hot because it'd be dropping all of that voltage all the way down to 3.3 and dissipating the excess as heat. So an alternative would be to go to switch mode regulator, but generally this sort of structure I've used many times and it works very well. coming in with doing the majority of your drop using a switch mode regulator, which is very power efficient so it doesn't get hot. And then the final supply to the MCU, another 3.3 volt rail with a small linear regulator, which gives a very smooth, clean output. And because it's only dropping from 5 volts to 3.3 volts, it doesn't get hot at all. It's not doing very much work. So anyway, that was a bit rambly, but that was my general thinking behind. That's the way we've got this 3-stage power system with raw 12 volts, 5 volts, and 3.3 volts in that linear sort of arrangement. And I mean linear in terms of sequence, not linear versus switch mode. Then, okay, so Wagon Loads asked, do I want to send this device to send fail reports over Wi-Fi? And I noticed there are a couple of other responses to that, people talking about Wi-Fi, and that I'm not really going to use Wi-Fi. Oh, just on that previous thing, Javier pointed out the buck do so much noise and you need to put filter or LDO for a clean reference. Yeah, so that is one of the reasons that I like this combination. We get the efficiency of the buck regulator, the switch mode regulator for doing the bulk of the voltage management, and then we get the smoothness of the linear regulator for the final thing. Then, okay, so Wi-Fi. Yeah, I probably won't use Wi-Fi. The ESP32 is kind of famous for having Wi-Fi, and the ESP8266, that is its claim to fame. It's what made it so popular in the first place, partly. But it's also a good processor for other things. So Wi-Fi is going to be there just because the ESP has it, but the things I care about are the serial connection to the host computer and serial connection down to the Kayo and CAN bus to other devices on the production line. Wi-Fi might be used by some people, but I'm not really going to use it in this application. Oh, Johnny says, oh, this is in relation to the pull-ups, the strapping pins and things. Johnny says, I forgot the pull-ups on my last board and it stayed in reset mode. Oh no. Yeah, I have forgotten pull-ups and pull-downs and things too. And yeah, and Stephen says, I accidentally put a pull-up on one of the strapping pins instead of down and couldn't write to the flash. Yes. Oh, Wagon Load. So this is in relation to using Wi-Fi. I'm thinking if he puts onboard sensors, thermistors on output fuses, then it could send fail reports. Something went wrong. Now, oh, Wagon Loads also pointed out if 5 volts gets shorted, you lose 3 volts, 3 too. Yeah, that's true. That is true. The 3.3 volt rail becomes dependent on the 5 volt rail, but oh well. Yes. Where are we? Oh, Johnny says it's 4:30 a.m. here, time for sleep. Yes. Thanks for coming along, Johnny. That is a crazy time. Yeah. Now, something I'm not going to go into this right now, but something I've been thinking about is the possibility of changing this live stream to a different day and different time. I don't want to get into this right now, but this is just planting the seed. It would be convenient for me to do this at 9 a.m. on Saturday. So basically 1 hour earlier, which would make it less horrible for the people in Europe, and 1 day sooner. So it would become late Friday night in Europe instead of late Saturday night. And here in Australia, it would be Saturday morning instead of Sunday morning. But yes, I don't want to end up getting into a whole discussion about that right now. And I'm not decided, it's just that would allow me to get along to Jiu-Jitsu on Sunday, which I can't currently do. Yeah. So, where was I? Ah, that's right. Now, you're talking about putting things like sensors on the board or a temperature sensor or something. I'm not going to do that on this board, but it would actually be quite cool to have this reporting back via MQTT, different events that are going on. I'm not even sure if this is useful, but as it is accepting commands from OpenPnP and sending them onto the pick and place machine, as it could theoretically be connected by Wi-Fi to an MQTT broker, and then each command that goes through, it could poke it off, publish it to the broker, so you could watch on MQTT all of the commands and things that are going through. Probably not all that useful. Maybe useful for some debugging, I don't know. But yeah, that may be one use of the Wi-Fi. Cable tie says Saturday morning would be much better for me. Okay, that's it. It's sorted. Cable tie, just for you. Yes. Now, my stomach is going crazy. You know what? I just realized I need to eat. I only had a little snack and a coffee before I started because I was trying to get to, I was trying to get myself enough energy to do this. It's 12:30, so I'm at the 2.5 hour mark now. I really should stop. I should wrap this up. But where it stands now is the schematic is pretty close. Even though this sheet looks like a mess, the schematic is pretty close. All I need to do, all in inverted commas, like scare quotes, is pick pins for each of these functions. So the TX and RX going to the Kayo, and the piezo pin, what else was there? And CAN, TX and RX. So what I will do before next week is I will work out what pins I want to use, and then next week it should be very quick and easy because all we'll be doing, let's see, is there anything obvious here? No. Yeah, I just need to add I just need to move that reset down to here, connect it to the enable pin, add a boot mode button to IO0. That won't take long, it's just the same as this circuit. And then, well, let's just do a little bit of cleaning up. Clean up, let's just delete these. I'll leave one of them there, delete that. What have I got? TXD0, RXD0. I don't think I need these anymore because they were going to the USB serial converter. I2C, do I care about I2C? I have a feeling that I don't, unless I want to put like a little diagnostic screen on this thing, which could be cool. It's also unnecessary. So we've got CAN RX, CAN TX, Kayo RX, Kayo TX. Let's just move these a little bit. So I'm going to do some grouping. Move those, TXD, TX, blah, there, and these are the nets that I'm going to need to figure out for next time. So that grouping there, let's take that and put them where? Put them here for now, that'll do. Just stick that down there. That is going to end up coming out to here. That I don't need anymore. Yeah, I'll leave this schematic in a reasonably clean situation ready for next time so that we're not dealing with too much residual mess. All right, so let's move that over here. I think I'll stick it about there. That'll do. That'll give room to stick the reset circuit in there. Pin assignments, these aren't even correct. I'll just stick them over there, get them out of the way. Yeah, why do I even need this? I'm going to get rid of that. Move that over there. And now we should be in reasonable shape. Actually, I'll delete that. The more I do this, I'm kind of just doing it. Let's move that label temporarily. We'll group that, move that down here. Stuff it, I'm already doing it. So let's take reset to the enable pin and move that label to there. We don't even need a label on that net, but what the hell? We've got it, so it can stay there. Bring that down so that the 3.3 volt rails are aligned. Reset button is there. Then IO 0, same thing. Okay, so let's yeah, I need to fix the grid spacing on this. That's horrible. Let's do this. I might have to rearrange this a little, but it'll do as a starting point at least. I'll stick that there. In fact, I'm going to delete that, take that net down to ground. Yes, take it to ground, take that to ground. I'm going to take this one up to here and oh, I misaligned that badly. There we go. Okay, so now we have oh, yeah, that's not going to work. There, that's going to work. All right, so that should probably be on the other side of that resistor. Am I going to move them? Yeah, let's move them. Oh, come on. Let me move it. Okay, move that one to there, move that to there, that to there, and bring this one down. All right. Do that? Do I do that? Do I do that? I don't know. I'm going to do that. All right. In fact, let's bring that down a little bit. Oh, I want to keep those aligned, so that doesn't matter. Take them back up. So then they're more closely visually aligned with the capacitor. Okay, so we've got our reset button. S2, that is actually, yes, I'm going to change that value and I'm going to make it boot. In fact, I'm going to call it snoot. Because you've got to boop the snoot to boot. Alright, so IO 0 is pulled high by default. We've got a button to pull it low. Enable is pulled high by default. We've got a button to pull it low. We've got our USB connections here, which go to the upstream port. We've got ground and power for, yeah, I really don't like that. Okay, I'm going to make this, all right, I'm going to fix this layout. It's going to look much worse to start with, but trust me, it's going to be better when it's done. Oh, maybe I'm wrong. Oh no, if I get rid of this label, because I don't need a label on that net, and this, I don't need a 50 volt rating on that. So, something like that. I think that's less obnoxious. All right, so we've got 3.3 volts with a local filter capacitor. Yeah, that's less obnoxious. Still not as neat as I would like, but it'll do. It'll do. All right, now group, we're going to take, no, not new group, I just wanted to move it. Move group. I'm going to stick it over here to make it easy to get all of this on screen at the same time so that nets can be added to it. All right, I want to keep going. Like, I could get all of this done, but I'm already at 2 hours and 40 minutes, so I am going to stop. But you know, the funny thing is, as I've been messing around in this schematic, I actually forgot that I was using Fusion. This, at various times. I know that a couple of times I've gone looking for things in menus, but this has been, the experience of using this for the schematic and moving stuff around and adding parts and that sort of thing has felt totally natural, coming from an Eagle background at least. So that's a good thing. It hasn't really felt like I've been slowed down much by fighting the tool or not knowing how to do things. So yeah, I could very well, I mean, I haven't got to the PCB part of it yet, but I could very well see myself just using this as my tool. But I'm going to have to try KiCad as well for real on an actual thing with a recent KiCad and see how that goes as well. Now, to do is pin assignments for these nets, and then we can go on to yeah, I've got to fix the colors on this because that does not work. That is really hard to see, these things that are off the board. Size to fit. Yep. Okay. Next week we're going to be routing tracks. Hooray! Because doing this, once I know what these are, like once I know what pin I want for CAN RX and CAN TX, it is going to be a matter of a few minutes to just stick the nets in here, label them, attach them, and we're done. The biggest thing is just deciding what those pins are going to be. So next week, if I continue with this next week, the schematic should be finished in the first few minutes, and then we can be doing some board layout, which would be really cool. All right, I'm going to save that as well. Save, chong cha chong, and what am I doing? What am I doing? I think I'm trying to finish. Yeah. I think I am trying to finish. All right. Oh, I've burned all my energy now. Stephen says, use TX-RX0 for the Kayo. Yes. James says, John's stomach is a special guest on this stream. Yeah, my stomach is going nuts. Ooh, yeah. Oh, Matt, you're here. Thanks for coming along. The lane says time change makes it hard for me. I will find a way. I don't add much anyway. Yes, you do. You add by being here. Thank you, the lane, for coming along. Chip says time change proposal can work for Amy and him. Also might make the barbecue easier to attend. Yep. What it would do is disconnect the barbecue from the end of the live stream, which is not necessarily a bad thing. So, although depends whether the barbecue switches to the Saturday as well. I hadn't even thought of that. I was thinking of just leaving the barbecue on the Sunday, but it could become a Saturday thing. Right. Oh no, no, but then I would miss kickboxing on the Saturday for the barbecue. But if it's Sunday, I would miss jiu-jitsu for that. I don't know. We'll work it out. Okay. Wagon Load said, "Where are all my strapping resistors? Haven't done them all yet." That's what I need to. Yeah. All of these pins that go nowhere, that is what has to be resolved next week. But that will be quick. So there'll be a couple of these that will need strapping resistors on them, and some that will need to be assigned to these nets, and the rest will just be not connected. And I'll mark them as not connected so I know which ones I don't have to care about. But that is going to be for next week, I think. I am going to find something to eat. I need it, and maybe you need it too. Thanks for coming along. Feels like we're making a little bit of progress at least. It's amazing how long it takes doing this sort of thing when I'm talking about it at the same time rather than just doing it, getting into the flow state. All right. A lot of it is me explaining my thought processes, like why I'm doing things in a certain way. But anyway, it does help to explain. It helps to clarify things. It's the rubber duck approach. But I get good suggestions too. So thank you very much to everybody for the suggestions, and thanks for coming along. I'm going to hit the big red button to end this and collapse. So thank you. Go and build something awesome.